Okay, let's look at example 7 in page 4. Okay, still doing conditional probabilities, conditional permutation. Okay, so we are thinking how to arrange 3 men and 2 women in a row. Okay, so like let's say when you come to lecture theatre, you're sitting in a row. Okay, let's say maybe 3 guys and 2 girls. So how many ways of arranging? Okay, like sometimes when you come for lecture, it takes a long time for you to decide where to sit, because there are conditions. Like for example, maybe the 2 girls want to sit together. Okay, that's part 1. Okay, part 2 is, what if the girls and guys want to occupy alternate seats for some strange reasons? And the last one, the condition is what? The 2 girls are always separated by 2 men. Okay, for some strange reasons also. So how to do part 1? What if the 2 girls always want to sit together? We consider the 2 girls as one item. So right in front of me, there are 2 girls here. They are one item. So now, how do I arrange? How together? How many items? 2 girls, 1 item, plus 3 other guys. So altogether, 4 items. So how many ways to arrange 4 items? 4 factorial. But that's not the final answer yet, because the 2 girls, they can only switch place. They are still together. Okay, so times 2 factorial. So the total answer is 48. Okay, if you cannot understand that, okay, there's
somebody's head. They cannot make it.
The voice recording, right?
So just combine them, treat them as one item. Okay, so now they are all together 4 items. Okay, so how to arrange 4 items? Okay, you can think of it as 4 seats in a row. So how do I place these 4 items on the 4 seats? Okay, 4 places for putting 4 items. So the first seat, you can have any one of the guys or this extra item of the 2 women. Okay, so it can be Remy Ong. And okay, these 2, 1 item. Who's this one? The sailors. And who's this? Susilo, badminton player. Okay, so 4 items. So how many ways to occupy the 4 seats? The first seat, 4 ways. Okay, so now let's say Susilo sits there already. So now the second place, there are 3 remaining items left. It can be him, this item, or this sailor. Okay, so let's say it's him. Okay, 3 ways for the second seats. Shh, that's noise. Okay, then now the third seat. After a while, you can see the pattern already. You can either him or them. Okay, so 2 ways. Okay, because once they have occupied a seat, you cannot use them again. Okay, so this is no repetitions. And then the last place, of course, only 1 choice. Him. Okay, so this is 4 times 3 times 2 times 1. 4 factorial. Okay, of course, don't forget the last part of the working. These 2, you can switch them. Okay, so times another 2 factorial or times 2. Okay, so the total answer is 48. Everyone can understand this part? Okay, so all these pictures should be going on in your head when you're doing this question. Okay, even though you answer, you don't need to draw any pictures. Okay, let's go back to the lecture. Okay, part 2 is when the man and the woman can occupy alternate seats. So when you draw 5 spaces. There's only one arrangement where you can have the man and the woman in alternate seats. You must start with man, woman, man, woman, man. Okay? This is the only way they can have alternate seats. Okay, once you have put this down, then you think of how to arrange the 3 men. Okay, 3 men, there are 3 seats reserved for them. Man, man, man. So how many ways of arranging 3 men? 3 factorial. How many ways of arranging the 2 women? 2 factorial. Switch. Okay, so the total answer 12. You understand? Very simple working. Okay, then the last part is the most complicated one. Okay, now I want the two women to be always separated by two men. Okay, so between two men there are always two guys. Here there are not just one way of arranging them. Okay, there are two cases you have to consider. So part 3, your answer will have case 1 and case 2, like this. Okay, first one. Two women separated by two men. So you can put them like woman, then two men, the other woman, then the man here. This is one way. You can see the two women are now separated by two men. Okay, then you do the working for that one. Then case 2 is you can have man, woman, then separated by two men, then the other woman. Okay. So if you think about this, there are no other ways to have two women separated by two men. These are the only two ways. Okay, so once you have arranged case 1, case 2, you do each working. The working for each part is same as part 2. Okay, how to arrange your 3 men, 3 places, 3 factorial. Okay, now I will ask all of them to shift one seat to the right. Okay, now I want them. Do you think this one is a different arrangement? Almost the same, They all look around you. You are right and left, they are exactly the same. Even though they have shifted one seat to the right. Okay, now I ask them to shift one last time. Shift one seat to the right. This is a different arrangement. Now it's still the same arrangement. Okay, if you look to the right and left side, you can see the same people. Okay, so thank you very much. Let's give them a round of applause. Okay, so look at the diagram. This is what I was trying to represent. First arrangement, A, B, C. But now if they all shift by one place, then you see this one, A, B, C. It's actually still the same arrangement. If the A look at left and right side, you still see B and still see C. Okay, if they shift one more place again, actually it's still a same arrangement. So all these in the first rectangle here are considered identical, only one arrangement. If they arrange the other way, of course, A, B, C like that, this is a second way of arranging. Okay, so for arranging 3 objects in a circle, there are actually only 2 ways of arranging. Okay, so how do we arrange things in a circle? Usually, the way of doing it is to fix one object first. Okay, so just now like sitting a circle, maybe Michael sits there first, and then the other two will come in and arrange among themselves. So you fix one object, and then the rest of the items n minus 1 factorial ways. So total ways of arranging n objects in a circle is given there for you really, n minus 1 factorial. Okay, of course if the seats are this color, is when all the bits are same color. Can you have all 3 bits the same color? How do I get 3 bits the same color? Tell me. All red, yes. There are 3 reds, there are only not enough blues, not enough white, not enough green. So the only way to get all same color is only one way. Red, red, red. Okay, now more complicated one. 2 are the same color and 1 is different color. Now how many ways? Now you can have either 2 red and something else, or 2 blue and something else. Can you understand? They are all together only colors that can repeat. Same color. The only 2 colors that can repeat either red or blue. Choose one place. Either red or blue. White and green cannot be used. So after you have chosen colors, both the same color, how many colors left? If you choose red, then you only left with blue, white, and green. Okay, so only 3 colors left. Next 3 colors.